welcome back. So last time we created our level, our layout for the level, and I've added this picture I found of the first Super Mario Brothers level. And if you wish, you could have recreated this, like this groundwork and these stairs for our own game, or you could have created your own level. Doesn't really matter. I just went ahead and copied the layout of this level. So now if I go back to Godot, you will see it looks pretty much the same. And I've also added this collider here, so our player cannot go to the left. We only want him to go to the right. And also for these stairs, I just simply added collisions like we usually do. We add a static body and then a collider. So now if I run this, you'll see I can run, but we don't have a camera, so the screen doesn't follow. The player goes off screen. We don't want that. And there's also another issue. If I jump, you can see this is the wall where I cannot go further. But if I jump, I'm sliding downwards. That's because of our logic of walking, but don't worry, we will fix that. That's not too big of an issue. Okay, first thing, what we want to do is let's create a camera so the player can actually move out. And it's going to be really easy. I'm just going to select my player character, add a child node, and the child node that I want to add is going to be camera, and of course the 2D camera. Create that. There we go. Let's see where this is. Okay, it's over here. We can of course move it a bit like this. And then of course we have a few settings here. We want current to be on. And also, okay, let's if we run the game now. You can see the camera does follow the player, but it feels kind of off. So let's go back. We don't want the player to be able to see below the ground. So let's pull up the camera a bit. And also we have limit here. And for top, I will set it to be 0. And for bottom, I will set it to be 0 as well. On the camera. Alright, now you can see we only see the ground, just like in Mario. And now if I'm running, it feels more like a Mario game. Oops, there we go. Alright, we have the basic layout and the camera is now working pretty nicely. What we are going to do next is add obstacles. So if I go back to the Mario layout, you can see we have these blocks here. And then we have these blocks that can be destroyed. So some of these will drop coins, others will drop a power-up. We're going to add those. So back in Godot, let's go ahead and add a new node 2D. And this node, I'm going to call it, let's call it bricks. And let's now add a sprite. And let's drag our map tileset on the texture component. There we go. Let me find it. There it is. Alright. And of course, we want the vertical frames, we want them to be 2, and horizontal frames 2 as well. Alright, there we have our frame. Now you might be wondering, how will we know if the player can actually hit this? Well, we could go ahead and test it to see how far the player can jump. But that seems about right, maybe a bit up. Or you could also look at the player's Y position and then just move this up by 400, which is the amount that the player can actually jump. Now this is too far high, so let's pull it back down. There we go. And of course, we will need to add a static body. So let's add a static body. We have it here in recent nodes. I'm just going to select that. and I will add a child node, which is going to be a collision shape 2D. The shape is of course going to be a rectangle. All right. Where is the collision is here for some reason. Let's just move it down to the brick, and of course let's rescale it. All right. So let's now test this out. We could move it down a bit more. Let's do it. Let's do that. There we go. All right. Now we are hitting him. And I also feel like this is too small. So let's go ahead and just increase the size of this. The scale to maybe 0.1. Oops. It now, see what happened now, because the 2D node, the parent node, is located here, and the children are in a different position. So if I were to now move the parent node, you can see how I'm moving the children. We should have avoided that, but it's not a big of an issue. Don't worry about it. We will avoid that in the future. Okay, so this looks, I think looks better now. Let's go ahead and check it out. Okay, it's much bigger. Nice. We can just move it down a bit. Okay. There we go, Mario is hitting it. Now how this is set up, since we're going to have a power-up that lets us, that will increase our size. When we're big, we will be able to destroy these, but since we're small now, we can't really destroy them, so we're just hitting them. Also, there's still this bug that we're sliding. We're going to fix that very soon, so don't worry about that. Alright, so I'm now going to lay out the bricks for our level. Let's go ahead and we can simply duplicate. And of course, move it next to this one. We can duplicate again and move that as well here. There we go. Let me just check the layout of the level here. Right, so here you have some coins and a power-up. We'll add a power-up. We won't really be bothering with coins. So we'll only want this power-up. Alright, and these blocks. Okay, so I'm going to go off screen to add all of these bricks. I don't want to take up your time. It's very simple. You can do that by yourself. You know how. So I thank you for watching, and I'll see you in the next lecture. Goodbye. Hello and welcome back. So last time we made these bricks, added them to our level, and these bricks will be destroyable. So in this lecture we're going to go ahead and make sure that the player can actually destroy these bricks. And also I want to fix a bug. The bug is, I'm just going to show you. Okay, when we jump towards a collider, the player continues moving. We're going to fix that very easily, don't worry. Now, this bug really breaks the game. It feels really bad. But once we fix it, it's going to be much better. Also, for the bricks breaking, what I want to do is we will have a power-up later on, which will increase our size just like in Mario. And if we are bigger, if our size is increased, we'll be able to destroy these blocks. But for now, as this little guy, we won't be able to destroy them. So let's go ahead and actually first fix this bug of him sliding. Go back to our script, and let me just close the output so you have a better view of our script here. Now you can see here where we check for collision, we have this is colliding method here, and basically we check to see, first we get the normal. A normal is a vector basically of each collision that points to a direction, and from the ground here the normal is pointing upwards. And basically, if we want to check if the normal is pointing to the right or to the left, meaning so for example, this normal would be maybe facing to the right or to the left. We want to check if we are colliding with such a normal. We don't want to set our speed y to 0. So let's go ahead and check that here. So we say if normal equals vector2, and now previously we checked if the normal was 0, if the direction of the normal was 0 on the x and -1 on the y. Now we are going to check if it's 1 on the x, 0 on the y. And also we want to check, say, or normal equals to vector2 -1, 0. Basically, we're checking if it's pointing to the right or to the left. If it is, we want to do something. Basically, what we want to do is the following. We want to set the speed x to be equal to 0. So we don't want any speed on the x. The reason why we are hitting this is because our character is still trying to move to the left while he's hit the collider. So he's kind of moving downwards. He's moving down and to the left, so he's moving diagonally. This way we will avoid that. But also we need to say else if the normal isn't facing to the left or to the right, we can set the speed y to be 0. Basically, we set speed y to be 0 only when we are standing on these platforms. In here, you will see speed y will be decreasing and we will hit the ground much quicker. Alright, let's check it out. And you see now we don't have that bug. I can jump and I'm not slowly falling. Also here, oops, also over, let me just try and show you that. Over here you can see no more of that bug. Doesn't matter which direction I hit them, we don't have our bug anymore. Very easy fix. Now the game feels 10 times better. You can see how I can slide upwards now, just like in a Mario game. This was a very simple bug and the solution is very good. It feels much better. So yeah, that is done now. Let me just show you what I have planned later. You can see here that the bricks, I have made a node 2D called bricks parent, and here are all my bricks which can be destroyed. So basically all of these in the level. I recommend you do that as well. But what we will do in a later lecture, not in this one, because I don't want lectures to be too long and I don't want to cover too many different things in one lecture, is we'll get our player character and we'll basically just, when we pick up the power-up, we will increase, let me just find it here, we will increase the scale of our character, maybe for 222, and then it will look like he got a power-up, but also we'll need to increase the collision shape. So don't worry, that will be very easy. And that's something we'll do in a different lecture. So thank you for watching and I'll see you in the next lecture. Goodbye. Hello and welcome back. So last time we fixed some bugs. We also, now the camera follows our player. And now we don't get stuck in the air when we collide with a collider, which feels really good. What we want to do now is make sure that we can destroy these blocks. I am running now. And of course in Mario we can only destroy these blocks if we hit them from below. So if I were to jump on them like this, they shouldn't be destroyed, only if I hit them from below. That's exactly what we're going to do. We will be using math and calculations to figure out if we are hitting these bricks. If we are, we're going to destroy them. Also what I will do, we will do that in a later lecture, is back in Mario you can't go to the left, so we'll make sure that a collider is always following you, so it doesn't let you go left. We also can set the background color to be something more pretty. Let's actually go ahead and do that right now. And just go to the scene, project settings, render, and here we have the default clear color. Now let's go ahead and maybe try something bluish like this. Okay, let's see how that's going to look. I'm not sure how I like that. Let's see something else. Maybe a stronger blue color, like that. You can pick whichever color you wish. I'm just going to see how this looks. This looks... I wish I knew colors. Let's see. Maybe green goes good with blue. Let's check that out. What did I forget to set the color? Default clear color. Okay. Close. You know what? I'm just going to set it to be bluish. And later down the line, we will change it to a prettier color once I figure out which color looks pretty. Okay, but this should be good enough, I guess. Okay, so let's go ahead and actually create the destruction of these bricks. There are a ton of ways to handle collisions to know if we hit an object. Usually what people do is they would group all of these bricks in a group and then check to see if you hit one of those bricks, if the object you hit is from that group. If it is, you would destroy it. But we're going to be using some math, which is going to be much easier to do than just add these to different groups and then check to see if the object is in the group. You'll see what I'm talking about. So here I have my bricks. We don't care what they're called, we don't care where they are. What's important is that they're bricks, and we know the only condition for us to destroy them is to hit them from below. So let's go back to our script. I'm going to close the output so you can see more of the code. And here, where we check for when we are colliding with something. Here we have the normal. We get the collision normal of the object that we're colliding with. And now this gives us a ton of information that we can use to determine if we should destroy an object. So let's go ahead and say if the normal is facing downwards, so vector 2, 0 on the x and 1 on the y, that is for down. So if we're hitting a normal that's facing downwards, that means that we might be hitting a brick and that we want to destroy that brick. Let's go ahead let's go ahead and now create a new variable called, actually I think we don't have to. Let's say normal get, no, we can't get the parent. Let's go ahead and create a new variable called object, and this is going to get the collider, and we also want a object parent variable. This is going to be the object get parent. So basically the object parent is the parent of this object. So if we hit the brick, we get the collider, and then we get the parent so that we can get, here, let me show you. You see we have this brick here, but when we hit it, we actually hit the collision shape here, and then we get the parent, which will be the brick, and then we can actually destroy it and remove it from the scene. So let's go ahead and here, if normal is equal to, if the normal is facing downwards, we simply say object parent dot queue free. This is going to queue him up for removal, and I can show you that right now if I run the scene, run the game. If I hit one of these, you can see very easily we are destroying them. And let me show you, if I jump on top of them, they are still here. If I hit them from the side, if I hit them from the side, they're still there. They only get removed if I hit them from below, which is exactly what we want. We're also going to have a few conditions here. We don't want to destroy these bricks when we're small. We only want to be able to destroy them if we are powered up. Let's go ahead and do that right now in our script. I'm going to go up and create a variable. I will call it power. By default, I will set it to be 0. And now down here when we let me show, where do we collide? Is colliding here. When we are about to destroy the object, I'm first going to check if our power is greater than 0. If so, then we can destroy the object. If not, we don't want to destroy it. So let's actually now run the game so we can test this out. Currently power is 0, so we shouldn't be able to destroy these bricks, and we're not destroying them, which is exactly what we want. But if I change it to, let's say, 1, we will be able to destroy them. Let's see. And there we go, we're destroying them. Okay, I'm just going to set the power back to 0. And in a later lecture, we're going to add some nice particle effects to these bricks, because now when we destroy them, they just disappear, which doesn't really feel that good. It doesn't feel rewarding. We're going to have a particle effect of bricks kind of like splattering on the ground. It's going to look and feel very nice. And then we're also going to add the actual power-up that we can pick up to allow us to destroy the bricks, and also the collision that follows us. And finally, we'll be able to go into our enemies, and we will create enemy AI, which is going to be great. I thank you for watching, and I'll see you in the next lecture. Goodbye. Hello guys, and welcome back. So I've noticed there's a slight issue with how our player is set up, which we will fix in this lecture. So if we select our player character, you can see this box here. And this is actually the position of the player character kinematic body, whereas the sprite, collision shape, and camera are on a separate location. This could cause some issues later on with our game. So we're going to go ahead and make a few changes that would have been necessary anyway. So first of all, what we will do is we will make sure that the player character is its own scene. So how we can do that? Very simple. We can just right click on the player character parent node and select save branch as scene, and then I will save this as player character scene. Save this, and now I can go ahead and open up the player character scene, and you can see we have our player character. I can move him around in the scene, and any changes I make to this character are also made here to this one. So for example, if I, let's say, click on the sprite and set the scale to be 4:4, if I save this scene and go back to the world, you can see that the changes have been made here. And this is very handy for instancing. Later we will create a enemy, and it will be its own scene, and then we'll just call it into the level created, and it will work perfectly. Let's just now reset the scale here. Okay, and now if we save the scene again, the player should be fixed in the other scene, and it is. Okay, so how should we fix this? Well, basically we gotta fix it by changing the positions of these. So let's go ahead and find the position of this node. Let's set it to 0, 0, top left corner. Do the same with the sprite, with the collision shape, position 0, 0. And do we need to change the camera? I'm not too sure about that, but let's no, let's actually check this out. Let's go back to our scene, and now what we can do is we can actually just no need to do that. We can, well, we could, let's delete the node here, the player character node. Yes, delete it. And we can click on this sign here, instance a scene file as a node, and go ahead and get our player character. No parent to instance a child. We gotta select the world and then the player character scene. And there we go, here's our player character. Let me just move him down a bit. And let's see if I run the game now. You can see everything is working properly. But now there's a bit of you can see how he's kind of like on top of the bricks, which looks good, to be honest. I like how it looks. It kind of feels like he's standing on top of them rather than floating above. So there we have it, a very simple fix and a very important lecture for instancing. You will see this is going to be very, very important later on, because now we can make any changes to the player scene, add anything, whatever, and it's automatically going to be changed for the player. You can understand how this is going to be useful when we have a ton of enemies, and instead of just copying them, we just create one, have a separate scene for him, and then just instance him. Also, in the next lecture, we're going to continue with instancing. You'll see we will create a particle effect for destroying these bricks. Right now, when I hit them, they just disappear. So we will create a separate scene to be a particle, and whenever we hit this object, we're going to create that particle effect, and it is going to feel and look much better. Right now, it feels kind of empty. There's no destroying bricks doesn't feel rewarding. It should feel rewarding. So I thank you for watching, and I'll see you in the next lecture. Goodbye. Hello and welcome back. So last time we created a separate player character screen, which is really important because now we can instantiate the player character in any scene, any level, and he's going to have all of these components that we defined already. This means that we don't need to recreate the player in each level. We can simply use this one, since it already works just as we have intended it to work. Alright, so in this lecture what I want to do is I want to create a particle effect for when we destroy the bricks. So now if I run the game, I can run around, and if I destroy the brick, it just disappears, which looks really boring. You should feel rewarded when you destroy this, so that it encourages you to destroy them more. So we're going to do the same thing we did with the player. We will add a separate particle scene, which we will instantiate whenever we destroy one of these blocks. Alright, so let's get right into it. To create a particle effect in Godot, it's very simple. We just simply select the world node and add a new node. The node that we want to search for is going to be particle 2D, so simply type in the search here particle 2D. You can see we have a particle attractor. This basically acts as a black hole, which we will not need in this game. And also we have particles for 3D games, but for us a 2D particle node is exactly what we need. So let's create it. I will rename it to, let's say, bricks particle. And I can now move it here to the center. Let me zoom in, and this is how it looks like by default. Now here in the inspector tab we have a ton of options. First up is the amount. This is the amount of particles that are being generated. Now it's set to 32, but if we decrease the number, you can see that many more particles, fewer particles are being created. And if we increase the number, there's many more. Let's set that to something like 40 for now, because we still aren't sure what we want to do with this particle. Then we have lifetime. This is how long the particle will last. You can see when I'm changing the value that the particle is becoming longer, since the lifetime is longer. Then we have the time scale. This is basically the speed of the particle. If we increase it, the particle is simulating faster. If we decrease it, it is simulating slower. I will set it back to 1 as well. Then we have the pre-process, the emit timeout, and emitting. Now this is very important. Emitting, when it's set to true, it emits particles. What we want to do is when we hit this block, we want a kind of like burst of particles, and then we want it to stop. So we don't want it to be emitting like this. How we can get around this is the emit timeout. If you set that to 0.2, you can see emitting is now stopped. And if I re-enable it, it starts and then it stops. So that's something that we will do, but for now I'll set emit timeout to 0, and emitting I will enable it so we have a live preview of our particle. Then we have the offset local space. If it's using the world space or local space, I will set it to be local space. And here we have some familiar settings. We have texture and horizontal frames, vertical frames. Now what we can do, and what I will do, is drag the map tileset into the texture field. And now this looks very hideous. We don't want a particle to look like this. So let's just tell Godot that this actually has 20 horizontal frames and 20 vertical frames. And then we have something that kind of resembles the bricks. Finally, we have in parameters we have direction. If we set this to 90, this will of course be emitting at 90 degrees, but we will leave the direction at 0 since we will set the spread to be 180. You can see now the particles are kind of spreading in all directions. This is what we want. We want this to explode, the brick to explode as we hit them. We have the linear velocity, of course the velocity of the particles. Set that to maybe, I don't know, 130. Maybe that's too fast. Let's set it to 100. Or maybe 80. When working with particles, you really have to test them out a lot to understand what you need to do. There's no set way to do something. You just gotta experiment. Then we have the gravity strength, which I will increase to maybe 20. I think this velocity is too much. Let's set it to 50. Okay. We also have gravity direction, which we will leave at 0. And then we have here initial size. I will set the initial size of these particles to be maybe 4. That might be too much, maybe 3.5. 3. Alright. So now they're bigger and they're getting smaller over time. And here we have randomness. Now this is very important to make particles much more fun. So for spread, we will set the randomness to 1. We will also set the randomness of velocity to 1. Then we will set the gravity strength to 1. And the result, also set the initial size randomness to 1. The result will be that every time we create this particle, we will have different results, which will in turn result in a better feeling for the player. Because if the particle was always the same, that would be very boring for players. If we do it like this, it will be different each time. And finally, we can assign a color like that. There we go. Now it looks really good. Alright, now that we are done with the particle, I'm going to select it and right click, save branch as scene, brick particle scene, save it, and let's open up our bricks particle scene. Here we have it. Alright, now what we have to do is of course set our emit timeout to 0.0, let's say, and see how it would feel if we instantiate it in the game. Alright, we don't want that, so we need more particles. Let's say 250 emitting. Alright, that is okay. And let's actually set the timescale to maybe 3. There we go. That's a good effect. Alright, now we're ready to create this particle when we destroy a brick. Make sure that the emit timeout is 0.0, and you will notice now that emitting is set to false. It's turned off, and if we turn it on, it turns off again. So we will have to re-enable this through a script, so don't worry about that. We can now close our particles scene, go back to our world scene, and let's now delete the particle. Since we are going to be instantiating it through a script, the player script. Back in our player script, let me just close the output and go this. Now we need to create a constant. So constant, I will call this bricks particle scene, and this is going to be equal to preload. We basically preload the scene, and now we need to specify the exact location of this scene. For me, it's going to be resources, 2 slashes, and bricks particle scene.tscn. There we go. If you specified the path incorrectly, you will get an error message. In my case, it's correct. If you have folders or something, just be sure to specify the correct path. the path is usually here. You can just copy that and then the name of your scene. Alright, now we have our scene preloaded, and let's go ahead and actually instantiate it. When do we want to instantiate this? Well, when we actually hit the brick. So this is here, when we go ahead and remove the brick. Let's go ahead and create a new variable. It's going to be the particle effect, and it's going to be equal to brick particle scene dot instance. So now we create the instance of the scene, and now we can use this to access anything from our particle scene. We can also change the position. You'll see many things. So first thing we need to do is actually turn on emitting. So particle effect get node, and the only node that we can get in the scene is, well, the parent node, which is this dot. And here what we have to do is set emitting true. So we need, of course, to set emitting to true, because you saw that when we enable it, it disables automatically. So we need to do that through a script, and this is how we do it. Alright. Now we need to set a position for this game object, for this scene that we're instantiating into our scene. By default, if you didn't do anything, it would be on the same position as it is in its own scene. So we have to, well, change the position. This is going to be very simple. Particle effect, set position. The position that I want this to have is going to be the position of our player, and maybe minus on the y-axis. So maybe minus 20 pixels on the y-axis. There we go. Now we have instantiated it. We have set emitting to be true, so the particle can emit, and we have changed the position of the particle. But one thing is missing. We need to actually add the particle to the world scene. The world tree, sorry. We need to do that. So let's go ahead. That's very easy, don't worry. We simply get the tree, then we get the root of that tree, and we simply add the child. Which child are we adding? Well, we are adding the particle effect child. Particle effect, there we go. Alright. That's about it. So let's go ahead and start test to see if this works out. And let's run it, and there we go. We're getting these particles, and immediately the game is much better. The particles are very fast, they're responsive, they feel very good. When we hit the brick, we destroy particles, and it just makes me want to destroy these bricks. Right, there we go. You can see how easily with particles we give depth to our game. We'll also have enemies, and we'll have particles for enemies, and you'll see the game will be very polished by the end of this course. Alright, thank you for watching. This has been it for this lecture. I'll see you in the next one. Goodbye. Hello and welcome back. In this lecture I want to take a small break from coding, and I want to do some art. We'll add clouds to our game, we'll also add pipes, and we will talk about a small issue that we have with how our code works for collision, and we will of course fix that issue. So let's go ahead and actually implement these resources. You will have these two files, of course, for download, the cloud and the pipe. I will drag them into Godot and import them for 2D. Alright, now we don't need to actually go click add new child node, add sprite node, since we are we can simply click on world on the world node and drag the cloud to the level. There we have our cloud. It of course is added as a sprite. And let's just increase the scale of this cloud. There we go. And now I will duplicate it. Move this one maybe here. Then I will duplicate this one. And move that maybe above. And now I will select both of these clouds and add them as a child of this cloud. And then I will duplicate this cloud and move it to the left. Alright. There we go. And then of course I will duplicate it again and move it to the left. And let's do that one more time. Alright, now I will select all of these clouds and add them to the parent. There we go. Now if we run the game, we'll be able to see these clouds and the game looks a bit better. Alright, let's now add our pipes. For pipes, of course, we want to collide with pipes. We won't ever be colliding with clouds. So we want to add a static body 2D because the pipes will never move, but we'll still be able to collide with them. Then we will need, of course, a collision shape 2D for this static body, and of course the sprite for our pipes. Let's select our static body and move it. Here it is. Alright, the collision shape will of course be a rectangle, but we don't know yet how big it is, so first we need to import our pipe texture. There we go. And I think this pipe is too small, so I will just increase the scale to 2. There we have it. Alright, move the static body to here. And now, of course, we can finally increase the collider. There we go. Alright, that should be good. Okay. And I will just rename static body to pipe. And I will save the pipe as a scene. So pipe scene. There we go. And now we have our pipes as well. And we can jump on them. We can hit them. There we go. Works perfectly. Now I want to show you the problem we have with collision. Maybe some of you figured it out. So if I place this pipe here, where the bricks are, of course this will never happen in... You'll never have such a scenario in your game because it looks really bad. But what if I hit this pipe? If I hit the brick is going to be destroyed. But what do you think? If I hit this pipe, will the pipe be destroyed? Well, it will, and the game will bug out. Why was the pipe destroyed? Well, because that's what we specified in our script. We said if we hit an object and the normal is facing downwards, so basically any object that we hit from below, then we want to destroy that object if our power is greater than 0. Now we don't want this to happen because what if we have an enemy that's like walking here and it just falls down and we hit it from below? Of course we should take damage, but in our case we will destroy the enemy. So we need somehow to check to see only if we hit the bricks from below. If we do, we want to destroy them. So let's go ahead here. We can check that we have the object parent variable. So if the object parent is in group, and if the group is called, let's say, bricks, then we will check to see. Of course, we need now to move this code. Just hit tab. So now if our object that we hit from below is in the group bricks, we will destroy it. How do we actually set an object to be in a group? Well, let me go to my bricks. I will select my first brick, click on node, and here I can add the name of the group, which is going to be bricks, and I will add this brick to the group bricks. There we go. And now if everything works as we told it to, we should be able to destroy only the first brick. Let's test to see if that works. And there we go. We destroyed the first one and we cannot destroy the second ones because only the first one is in the group bricks. Now sadly we cannot select all of these bricks and add them together in a group, but that is good. I wanted to show you by example why it's important to have separate scenes, object scenes. Now if we created the brick as a separate scene, we would only have to add one of it to the group and all of them would be added to the group. But this way we learn from mistakes what the difference is and how much time we actually would save if we worked with instancing scenes. So let's add all of our bricks to the bricks group. This is going to be very useful when we have our enemies, because the only way we can actually kill enemies in Mario is if we jump on them. So basically we will check if we hit something from above, and if it's in the group enemy, we will destroy it. Of course, we always hit the bricks from above, but they are not in the group enemy, so we don't destroy them. Let's go ahead and bricks. Whoops, not signals, groups. There we go. I should have added, all bricks are now added to the bricks group. And if I now test our game, we should see that everything is working perfectly. There we go. Just to make sure, I will try to destroy every brick. Sadly, I cannot get to these, but it doesn't matter. Alright. And there we go, we destroyed every brick in the game. And of course, if you add new bricks, be sure to add them to the bricks group. Oops, I died there. We will also add def. You can see I still have control of my character. So we will add def once you fall through these pits. But all in due time. Thank you all very much for watching, and I'll see you in the next lecture. Goodbye.